Hi guys, it's Miss Reams. Time to take some notes on dilations. So grab your geo books, go to the CP19 section, and let's get started. Okay, we have two vocabs, so go to page 57. We have two vocab words. The first one would be dilation. A dilation is a process of shrinking or expanding an image without changing its orientation or shape. So take a look at these two triangles. Okay. The only difference between these two triangles would be their size. Okay, the orientation's the same, the shape is the same. The only thing that changed was the size, and that's what dilations do. They either shrink or expand a shape. So you want to pay attention to the way the letters or whatever it is describing the image or pre-image is labeled. So look at this is triangle A. And this is triangle A prime. Remember that from first semester? Prime was what it was labeled as once we did something to it, like we rotated or translated or reflected an image, we added a prime to it, a prime symbol. So the same thing works here. This would be our original image. We call it the pre-image. And then what it looks like after we're done, we call it prime. So this would be just image. So we call it A prime. Okay, so notice that after dilation, the dimensions stay in proportion. Okay, so these are proportional. They're not congruent. Congruent's when they're exactly the same. These are similar. We'll get more into that later. Okay, the other thing to put in the vocab section would be scale factor. So a scale factor is a number that determines how an image expands or shrinks. So if a scale factor is greater than 1, then the image expands, it got larger. If a scale factor is less than 1, then the image shrinks, it got smaller. Okay, and you're going to need to be able to figure out what the scale factor was given two images. So the way you do that is by using this little fraction here. It's new over old. So new would be your prime, like A prime, triangle A prime, and old would be triangle A. So this would be the image, and this would be the pre-image. So one way I like to remember it is no, new over old. No, Ms. Dreams, I don't want to do dilations. Too bad you have to. So no. New over old. Scale factor, new over old. Just remember no. Okay, let's try some. Okay, so you should be in the notes section for CP19. Take a look at this photograph. It's been dilated. So just draw it, just do a quick little sketch. You don't need to make it perfect. What you want to do is figure out the scale factor of this dilation. So here we have A, and here we have A prime. So that's going to let us know which one is new and which one is old. Okay, so the new one would be the prime one. So that's the new, and this would be the old, or the original. Now remember that scale factor is new over old. So to determine the scale factor, you want to choose two corresponding sides. So if you look at this length, it corresponds with this length. Okay, so this one corresponds with this one. And we are going to go ahead and plug that into our new over old formula. So the scale factor would be new, which is 9, over old, which is 3. So we can go ahead and reduce this or simplify it down to 3 over 1, which we know is just 3. You can also write it as 3 to 1. That's another way you can write the scale factor. So remember what we put in the vocab section. If the scale factor is greater than 1, which it is, then it was an enlargement. If it's less than 1, then it would have got smaller, but it didn't. Our scale factor was a number greater than 1, so we knew that it got larger. Let's try another one. Okay, problem 2. So pause the video, draw this out in your geo book, and then we'll get started. Okay, so this time, what is the scale factor of the dilation from triangle DEF to triangle ABC? So we don't have the A prime, B prime, we don't have all that. So we have to read it and try to figure it out ourselves. So we're going from triangle DEF to triangle ABC. So that means that triangle DEF had a dilation done to it to make it triangle ABC. So that means that ABC is our new and triangle DEF is our old. So if it went from a larger triangle to a smaller triangle, then our scale factor should be less than 1. Let's try it and see. So what you want to do is go ahead and pick 2 corresponding sides. And with this one, if you're not sure if it's what sides go together, you can look at the order of the letters like we did it during first semester. So DE, side DE, will correspond to AB. So side DE corresponds to AB. And looking at the order of the other letters, DF would go with AC. So DF goes with AC. And FE, or EF, would go with BC. So you want to be able to figure out what sides are corresponding. Okay, and then you just pick 2 of them, but they have to be the same ones. They have to be the same shape if you're going to put shapes around the numbers. Okay, and so we're going to figure out the scale factor. Remember, it's new over old. So let's go with the circles, 9 and 6. So new would be 6, old would be 9. Okay, we can go ahead and simplify that by 3, and we end up with 2/3. So we can write that as a decimal. You can keep it 2/3, or you can write it as a decimal by dividing 2 by 3, and you get 0.67. You can write it like that, or you can write it 2 to 3. So lots of different ways you can represent scale factor. Okay, let's keep going. Okay, problem 3. This one's pretty cool. So we have to actually perform a dilation. So we're going to take this triangle, OMG, and dilate it by a scale factor of 2. So just draw a quick little graph in your book and then plot the OMG, triangle OMG, in the correct spots. Okay, this might take you a little bit longer, so definitely pause the video and draw the triangle on a graph. Okay, so the first thing you want to do is go ahead and find the coordinates of O, M, and G. Okay, so the coordinates of O would be -4, 1. The coordinates of M would be 3, 2. And the coordinates of G would be 2, -2. Okay, now once you have that, then we're going to, because it's a scale factor of 2, we know it's going to get larger. But what you're going to do is multiply each part of the coordinate by the x and the y. You're going to multiply both of them by 2. And you're going to get your new image. coordinates. So O prime would be negative 4 times 2 is negative 8. 1 times 2 is 2. M prime would be 3 times 2 is 6, and 2 times 2 is 4. G prime would be 2 times 2 is 4, and negative 2 times 2 is negative 4. Okay, now, cool part, you go ahead and plot your new points, your prime points, and you'll see that the triangle is going to expand by a scale factor of 2. So we're going to plot our points. Negative 8, 2. That's going to be O prime. 6, 4. Here. That's going to be M prime. And G prime would be 4, negative 4. Here. G prime. Now, all you have to do is connect the 3 points, and you'll have an enlarged triangle. Now, I know my lines are not going to be straight, but you guys can do a better job than I'm about to do. Okay, not bad, I guess. So that is what a scale factor of 2 looks like, a dilation by a scale factor of 2. Pretty cool, huh? Let's try another one. Okay, problem 4. We're going to try this again, but this time we're going to perform a dilation from the origin on figure MASH, so quadrilateral MASH, using a scale factor of 1/3. So 1/3 is less than 1. So this should get smaller. We will see. Okay, so what we want to do is find your the coordinates of each vertices. So we have M, A, S, H. Okay, so M is negative 9, 3. A is 3, 3. S, 6, negative 6. Oops. 6, negative 6. And H is negative 6, negative 6. Okay, now we're going to multiply each number by 1/3. So we have to multiply by 1/3. Multiply by 1/3. So when you multiply by 1/3, what that really means is that you're dividing by 3. You're dividing your number by 3. So what we end up with is, okay, so M prime, when we divide by 3, we end up with negative 3. When we divide 3 by 3, we end up with 1. A prime, 3 divided by 3 is 1, and 3 divided by 3 is 1. S prime, 6 divided by 3 is 2. Negative 6 divided by 3 is negative 2. And H prime, negative 6 divided by 3 is negative 2. And negative 6 divided by 3 is negative 2. So we need to go ahead and plot our new points. M prime, negative 3, 1 would be right here. M prime. 1, 1 right here. That would be A prime. 2, negative 2 down here. S prime. And negative 2 right here would be H prime. So when we connect them, oh, look how cute. That's what happens when you do a dilation by a scale factor of less than 1. The image gets smaller. Pretty cool. Okay, well that was it for notes for CP19. I hope you have an awesome day. Guess what? I miss you guys. I hope you guys are doing good. Keep up on your work. I'll be seeing you soon. Bye.